I'll just start off a little bit about central heating. Some of you may or may not know, I'm Lyle Smith, so I'm the Managing Director of Central Heating New Zealand. My brother and I started the company 18 years ago, and so we've concentrated on hydronics, mainly in the heating line, obviously. So with Underflow and radiator-based systems. We're a family-based business. Last year we partnered with Rinnai, a New Zealand company that has a Japanese parent and that have well known for products that are utterly reliable, and so we're thrilled to be partnered with them. They're a great help to us, and so there's a bunch of us here, and our purpose pretty much has always been to raise the standard of heating in Kiwi homes and businesses. I don't think there's too much of an argument that Kiwi homes are fairly poorly heated mostly, and so that was the driver for us right back in the early days, and still is, that we believe there's a long way to go, and so that's why we get out of bed in the morning. It keeps us focused and figuring out what we're doing, and so we're trying to assist New Zealand to have a better standard of heating. So background, we've done a few projects in the residential and commercial markets. We work with specifiers such as architects and consulting engineers to develop the systems that are going into the projects. We have a dedicated after sales team, and we do industry training here in this very room and in a working products room next door, and then some practical courses to do with underfloor and radiator installs, and so it keeps us pretty busy. And we have a small install division here in Christchurch that really assists us in R&D, especially on this type of product that Alexander has, so we become experts and are able to pass that out to the customers that we're selling products to, so it's very useful for us to be able to be involved in that. Suppliers are pretty important to us. We're a long way from the main hydronic market in Europe, and so we have a raft of suppliers, and you can see some of them there that will be more well known than others. But yeah, it's great when we have an international supplier come here. It's pretty rare. We're a long way away, but it's very important to us to have a decent relationship and partnership, because they're the guys that back up what we do, and we rely on them. So just a little bit about what we do. We go from the heat generation, so we sell, specify and sell a range of heat sources from gas boilers, diesel boilers, air to water heat pumps, and ground source or geothermal heat pumps. We also do some biomass boiler products, but essentially it's related to combusting products and refrigeration products. And then the emission system, so Underflow is a large part of what we do. There's many different ways of doing it, and New Zealanders have latched on to the underfloor heating system as a lovely form of heat for a home. And then of course the radiator systems that we all grew up with in schools, and unlucky for those of us that were in hospitals and prisons, but it's always been there in the institutions, but it's never been that popular in residential homes. That's changed, and now people are a lot more free and familiar with that type of heating appliance. It's a great form of heating. So the Kiwi situation, and you'll all be familiar with this. In fact, I was just speaking to the editor of Master Plumbers magazine, and we did an interview with her over the phone, and she was saying, "Oh, I've just built a new house, and we just put a log fire in." And she was English, she was Pommy. How long have you been out there? 4 years. "Oh yeah, what did you put a fire in for?" "Oh, it was just what the builder told us we needed." And so I said, "Well, unfortunately, you've done the classic Kiwi thing, and good on you, but that's why it's a bit hard to break the mould." But anyway, we all know what the deal is there, the singular heating appliance, and the numbers are pretty interesting. 25% of the market's based around log fires, 60% of the market's based around the high wall air-to-air units, and the hydronic or warm water central heating, very small, 2% figure there. That's changed in the last 20 years. When we started off, it was minuscule. We weren't the pioneers, but it was pretty small then. It's definitely grown. It's growing at about 20% per annum. So it's an interesting market to get into, even though it's very, very small. And of course, the central heating difference, what do? Well, we heat more of the home, and it's a much nicer type of heat. It's an even heat, and unless you've lived with it, it's pretty hard to describe. But the fact of the matter is, it is a feeling, so we're selling a feeling, it's a comfort feeling, but it's also a health feeling too. And that's the benefit of having a good full home heating system that's evenly heated radiantly. It's a very, very nice feeling. In the radiant heat, you'll all be familiar with this type of a chart that shows that ideal heating, we like a little warmer at the feet and a little cooler at the head, and then the types of heating along the way that are different. Underfloor heating is the most close one that mimics that ideal, and as we go along and get to the single heating appliance, we have this uneven style of heat, and that's what we're used to as Kiwis, but the rest of the world doesn't live like that. So some of the projects we're involved with, you'll be familiar with typical family homes with radiator-based systems, some more impressive homes where people spend an awful lot of money. So this is one where there was a couple of ground source geothermal heat pumps heating a 500 square metre house in Queenstown with 2 plunge pools outside heated to 40 degrees all year round. So from basic stuff to tricky stuff. Boutique luxury lodges, there's one in the Lindis Pass that's got some fairly interesting trench heaters underfloor, geothermal, gas boiler backup things, so that's common. And then even up into larger projects such as the Convention Centre in Christchurch, which has underfloor and trench heaters in it. And so the relationship with Variotherm goes back quite a long way, for about 2013. We got involved with them and have worked with them along the way. One of the things we like really quite a lot about Variotherm and a European supplier is that they're all about the details. They're not a huge company, they're a smallish company, as Alexander will explain, but they're very detailed, and that detail runs to their installation and design guide manuals. So the design guides for all their products are very in-depth but clear, simple English, great translations, and really, really great to follow. So that's a huge difference. We don't get that from many European suppliers at all. It's such a given over there that they don't even bother with documentation. But with Variotherm, we get fantastic documentation, and it makes it so much easier for us to assist people like you to get these projects across the line. So that's pretty much the background there. Let's sit back, listen to Alexander. He's got a lot to tell us, and some of it, of course, will be at different levels. We're all at different levels, so bear with us, and those that it's too basic for, and those that it's over the top. Hopefully it's going to be good. So welcome to Alexander. Thanks very much for coming.
Well, I think the keyword for me was simple English. You will hear it immediately. I'm not a native speaker. I do my best for you, and even for me, that you can understand my words. More what I want to tell you, the story, and bring you to some feelings with heating and cooling systems. What we have done in the last years, Variotherm. My name is Alexander. The last name you can forget. It's easy. It's not easy to pronounce for you. Variotherm is a small family business, still small. My father founded the company in 1979 with an idea to produce heat exchanger for skirting radiators. And this time we call it baseboard heating because 14 years before he started to import baseboard heating systems from America. And this is myself right now in the picture. So you know how long I'm in the business. Very long time I have not known that I'm in the business, but yeah, that's it. And my oldest son is there's the same picture from my oldest son, and he's now running with the business with me. He's 26 years old now. It's still a family business, you know? So we are an industrial company to produce that what we are doing, and I will show you some things what we are doing now. The history from Variotherm, 40 years now. We celebrate last year 40 year existing from Variotherm. We start with the skirting radiators. In that time, there was not the focus on radiant heat, on comfort and well and health so much, but it was already there with this products, skirting radiators and skirting heatings, because to cover cold surfaces, cold outside walls, what you in real do with skirting radiators, so a long distance on the outside walls where the windows are, means that you cover that cold surfaces with our room where we are, and that was the way to start for Variotherm, this thing to heat surfaces. And in the 80s we start to produce stoves, but not fired stoves. We heat the stoves with water. We designed a brick with a pipe included, and with this brick we built only cozy areas, small sections in the living room with a high temperature, but water heated. There's a difference. You don't have to heat the stove with wood and fire only in a few moments a day. These stoves were heated all the time, central heated. This was our beginning to think and to work with heated surfaces. In this time, it was only heating what we have done. In the 90s, we start, late 80s and the beginning of the 90s, we start to make bigger and bigger surfaces, still just on the wall. There was no floor heating for us on the market in Europe. Underflow heating started in the 70s, the 80s were really expanding this product. My father and me, we fought many years long against the underfloor heating system, because in that time the surfaces from the surface temperature from underfloor heating were much too high. It makes not really maybe comfort a little bit, but not healthy. The feeds become too warm, and that was a really problem. And that was what my father and me, myself, were not happy with. So we need a long time to come from the wall to the floor. And that is something different, totally different to the rest of the market. To most of our competitors, they start with underfloor heating, and later on, because it becomes more popular, they jump from the floor to the wall and later to the ceiling. Yeah, the company was growing in this time. 1999, my father passed me the company over. I'm general manager, and now also the owner from the company. In the 90s, we had to develop a system for drywall construction. The reason was, in Austria, Germany, prefabricated houses become very popular. So we were the first time and years of our history, we only did plastered walls and concrete floors, and in this time we start to develop a drywall construction product just for walls in the first time. 1999, I have shown on the ISH in Frankfurt. This is the worldwide biggest fair for plumbing and heating and ventilation system. The first sample, very, very similar to this one, for a drywall constructed wall heating plate. In the first time we routed out the boards with a Locator hand milling machine, and fixed the pipe with a hammer in these routes. Very fast we could see that there is a market for that. In the first year maybe we sold 100 square meters, and in the next years we have to design and develop a production, and in the end we designed a machine where we can produce this product full automatic. I'm a mechanical engineer, and so we start more and more to change from an installation company in the first years. Later on we designed kits for self installation in our home market, more and more to business, and now we are officially an industrial company. In Austria we do have different chamber systems for trading, for installation, and for industrial, and now we are a small but very specialized industrial company, designed more and more machines. The next stage and develop what we have to do is the underfloor heating system, because the first, it takes not a long time that our installation companies and customers in Austria start to lay our wall heating plates on the floor. Because floor heating is popular, we need a underfloor heating system, at least in the bathroom, and it is not clever to lay this plate on the floor, because you have a lot of connectors and you never can cover the whole surface, because we do have a lot of different sizes on plates in our range, but for sure not exactly that to fill the whole floor surface. And then just about that, we had to develop a product, a product for a dry floor under construction. And in 2001, we start to design the Variotherm modular plate, which is now the most successful product in our range. 2005 we started the first machine. Now we have 4 machines to route gypsum fiber boards for the floor and for the wall. And at the moment we do about 220,000 square meters per year on plates. We route with 5 machines in total. In 2008 we developed a product, and Lyle talked about details. This is something what we take care every day, every minute. We are going deep into details. In my experience and in my opinion, for the success from the small company Variotherm is to take care of the details, because the sum from a lot of details will bring a perfect end result. That is our philosophy, and we developed our pipe. 1992 we start with the first multi-layer pipe with a structured surface. This is something what were really new on the market, and for surface heating and cooling. And in 2008 we developed the next generation with a profile surface. The profile is guaranteeing two things. One thing is that the plaster and the screed will be in a perfect contact with the pipe, so this is an optimal heat transfer. And on plastered walls and ceilings, yes, we are doing that in our Middle Europe. The plaster will become in a mechanical contact with the pipe. It is different to a smooth pipe. That is the 2 points from our profile pipe. Nowadays, in the last years, we designed an additional product with that gypsum fiber plates. This is an acoustic plate. An acoustic mostly used on the ceiling. We'll come later on to this product. This is our latest development. And the company is growing. We designed, has to build new production areas, new offices, new machines. 3 years ago, we designed our own manifold. It's a glass fiber reinforced plastic manifold, which is, we'll see later, a perfect product even for heating and for cooling. That is what we are doing now. There is no difference anymore from the product, from the concept, from the design between heating and cooling. And this is for sure in the future will become more and more important. And the last 2 years we built a new office building because we need more space, new employees, and to show our products in showroom, meeting, and training rooms. And this new office building brought us, and especially for myself, a new knowledge, because in this office building we could really test the latest possible technique in heating and cooling. What does it mean? We run the building with a geothermal heat pump. Sometimes we do a free cooling, so we take the cold temperature from the ground around the building, transmit it into the floor, wall, and ceiling surfaces. But because of we have all the surfaces piped, the floor, the possible walls, and all the ceilings in the building. And for myself, I've never before such an ideal situation. The result is that we are going for heating with about 27 to 28 flow temperature. This is extremely deep, We do have in the winter between 0 and -10 degree outside temperature, and we are going with 27 to 28 degree flow. We believe that we have inside 23 degree room temperature, so the difference between the flow and the room is very little. That is on the other hand a challenge to control the system, and in the end we have to run through 24 hours with the same temperature, but the heat demand and the energy input is very, very low. The costs for the running system. And the same is in the summertime. We can go with a very high temperature into the surfaces with about 17 or 18 degrees, which is very high for a cooling system. And with the result that it is very comfort and very healthy climate inside. It's only our building. Variotherm, we are let's say a special team. We take care a lot on our nature. Most of our products are certified by some biological institutes in Germany and in Austria. We take care on our employees, on our area around the building. We do have programs for childs in our area which needs help. We collect money for that. We found money, sorry. And we do have a CSR team for our sustainable work to show what is possible as a company, and the employees and the people who are working in the company to give back to our area around. And therefore we won a lot of awards over the years. And the most exciting award is here to see the picture from the celebration. We won an award for our way to train our employees. Long life learning, was the theme. Very proud about this, an Austrian State Award. What are we doing? We are selling business to business. Our partners are general importers in different countries, and in Austria directly the installation companies. When you see the number, it's not a lot. In total, let's say we have 500 customers. In Austria alone, there are 4,000 installation companies. In Germany, 40,000 installation companies. So the market is very big. We have a very small range on customer. What does that mean? Our work is based on a niche market, on a special projects and customers who follow this idea to save energy and to create a really comfort climate. And we try to create partnerships and a relation with our customers, and we're doing 80% of our turnover with 20% of the customer, and that's the typical way for a special company. And worldwide, we do have 4 business partners, and 25% of the business partners are in New Zealand. So this is our faraway export market, and we are very happy about that. Very happy about the work and the relation with Central Heating New Zealand, as well as with you. And I hope you can take today something with you on the way, why we are doing that, what we are doing, and how it could be done in all these homes out in New Zealand to make things a little bit more comfort, or a bit comfort, and more energy saving. We designed in the last 40 years a lot of projects, more than 10,000 projects in total, and the number of square meters or meters from the skirting radiators you can see on this list. We will reach in this, for sure, 2020, 1 million square meters from this Variotherm underflow heating system, which is in the moment our most successful product. We're doing about 50% of our turnover just with the Variotherm underflow heating system. But we have to take care that all surfaces are in our focus as well, the wall and the ceiling. For sure, Variotherm is the company who did in the past the most square meters on wall heating worldwide. About 700,000 square meters in total. That's a lot. That's much more than all other companies can reach, and with a reason. This was our first product, the wall heating plaster, and about 275,000 square meter from the drywall wall heating system. Yes, that's so far to my company, and now I will come to the basics, why comfort, how comfort is working, and I'm talking just about comfort in rooms. In offices and living rooms, we need walls, the ceiling, and the floor. Comfort in general is very, very difficult, and easily I'm talking just about thermal comfort inside of heated or cooled rooms. Why do humans feel comfort or not? What we are doing with our heating and cooling system is mostly that we overheat the air. When we heat, we overheat the air and forget that the surfaces are too cold. With a high temperature radiator, for example, and in the summertime, the problem is that the surfaces around us are too warm. The glass is warm, the walls become warm after a while, and we feel uncomfort. Why do we feel uncomfort when this is like the picture? We are taking a lot of energy with the food and the drink into us, and most of this energy is transmitted in our body into warmth. Why? We have 37 degrees, and when you can follow a little bit this idea and think about the situation, that independent where we are, what you're doing, the 37 degrees is all the time constant. In the winter, in the snow, or in the summer on the beach, if you're relaxing or active and you do sport, all the time 37 degrees. This is a must for our body, otherwise we become sick or we will die. To stay on this 37 degrees, this is the challenge for the body, and the guarantee to have exactly all the time the 37 degrees is that we produce an over energy inside, the warmth, and we lose this temperature to the area around us. That's the way how the human body works to stay on this temperature. And the question, what we have now to answer is, we as an installation company, designer, architect, we create an area around our customer is this transport from temperature comfort or not? That's the question, the big question what we have to answer. I know mostly no one is asking this question, but this is the reality. We have to do that. The range between comfort and uncomfort is very small. So you know that from yourself, very little change in the temperatures is comfort or uncomfort. And we as a technical team here, we understand that the human body, as the heater in this situation, is working with the normal heat transmission, heat transfer mechanism, which are existing for any heater. We have 37 degrees, and everything around us is colder than we are. This is something normally we are not thinking about that. We have to transport temperature. We do not heat. We're talking about heating systems and think about to heat a room temperature, but this room temperature is still colder than we are. So we can lose and transport our temperature, what we have to do to stay under 37 degrees, by radiation. This means that we lose the temperature to all surfaces around us, to the ceiling, the wall, the floor, the windows, to the furniture. Everything is colder than we are, and we transport temperature. Convection, this is the transport from the body to the air. So the air starts to circulate around our body because we are warm, 37 degrees. The air do have about 22, 23, depends which temperature in the room, and starts to move. take the temperature on the way from our body, and that is the convection from us. Respiration, you know, we breathe in room temperature and out body temperature. It's a big delta T, and so we lose temperature on that way. Very important, for example, in the bedroom. That's the reason why it is important to have in the sleeping room a lower temperature than in the other rooms, because in the bedroom normally you are covered, you lay in the bed, so there's no convection, less radiation, so we need the respiration to hold the 37 degrees. The special point is the conduction, especially for the floor, because we are used to be in contact with the floor. So we are not able to fly, so we have to be in contact. We need to lose temperature with the feet, and that makes the underflow heating system to such a special product, because it is not comfort when the surface is too warm. And therefore, just with the underflow heating system, not with the wall, not with the ceiling, we have a restricted surface temperature, which is 29 degrees in living rooms, 34 in bathrooms or in peripheral zones where you normally are not walking. And that is an important point for the underflow heating system. And at last, we have five ways to lose the temperature. Is the evaporation. It's very flexible. It depends what you are doing. I'm sure I have now more than you, because I'm active here, or when you do sports. This is why are we sweating when we do sports, or we are sitting in a sauna? The body wants to lose temperature to stay on the 37 degrees. It's the only reason why we start extremely to sweat. In the end, it's a fight from the body to come to the temperature. When you're too long in a sauna, it is not possible to stay on the 37 degrees, and it is for sure not healthy. And in sport, wind is very important, so that the body can lose the temperature. You can see here a figure from the average, from all the different ways to lose the temperature. And the important part, the biggest part, is the radiant heat output from our human body. For sure not so known, but it is the reality and the problem, so to say, but this is our chance to make it in the right way, is that the range to feel comfort or uncomfort, and here is the heating side, here is the cooling side, the range is very small. Only 20% is the range. When you see the respiration, we have a big range, because we can start to breathe faster, to have more volume through our lung, but not with the radiant heat. The convection is 10% the range. It's important to have not too high room temperatures in the heating, or too warm temperatures in the summer for the cooling. And the game what we have to handle in the right way is to make a really good mixture between all these five possibilities, because if you want or not, all these five will happen in the same time, every second. And the question is this comfort or not? And what we are doing with our technique, with pipes, with radiators, with underflow heating system, with forced air, whatever, we influence the situation around us. And that is in the end of this section what I want to show you, the result. We influence how the human body from our customer is able to transport the temperature, what is necessary would happen anyway, in a comfort way or in an uncomfort way. It is really easy to create a comfort climate in rooms like offices and living rooms when we follow this section here. That means the radiant heat output from our human body in the winter must be a little bit reduced, and I'm using with a reason the word little bit. It is not extreme. Everything that is extreme is not comfort. So we have to reduce our radiant heat output a little bit. How can we reach that? When we heat a little bit the surfaces more than it is without heating. In summer, it is the opposite. We need more radiant heat output because when in a normal situation, when the walls, the ceiling, the floor is not cooled, so that we can transport more with the radiant heat transport. So once again, this is the situation, and now again a figure. You can see what is uncomfort. The walls in the winter situation, the surfaces are too cold. We lose too much energy with the radiant heat, and the rest is following this idea. And in the summer, we lose not enough with the radiant heat transport and feel uncomfort. The same situation with the comfort is when we rise up a little bit, we heat a little bit the surface around us, floor, wall, and ceiling. In the summer, we cool down the surfaces a little bit, and then you feel really comfort. And that is the way what we are doing since many years. Believe me, thousands of projects, thousands of customers can confirm that. They are very happy when they follow this idea, and it is not really complicated to do that. Only a little bit to heat the surface in the winter, we cool down the surface in the summer. The first step to comfort is the construction and the design of a building and rooms. Which material is chosen for the walls and the window insulation and so on. And what we have to do as a house technical company, installation and plumbing, more or less we cover the faults what are done in the design and in the material from buildings. We have to accept it. So when you can influence clever design, for example, we become not tired to warn customer to make too big window glass areas, because the windows is a critical element. Very cold in winter, too warm in summer, maybe for 10-20 days a year, very, very comfort, but the rest of the year, during the night and so on, it is not so easy. So we make a compromise, and that is the word what is important for our work. We need a compromise, the best mixture between all these physical rules to lose the temperature. Variotherm is a small company, but we have a lot of different products in our range, just about to cover cold and warm surfaces for heating and for cooling. You will not find any company to offer all these different products from one hand. Why do we have so many products? Because the house is built like it is built, the design is there, and we have an answer for every different design and material. Even if it is a glass, a concrete, or a drywall construction, we have a product to heat or cool these surfaces for our comfort. But first I want to show you and tell you a little bit about our drywall floor heating system Variotherm, which depends on 3 different components. One is the compact plate. It's a gypsum fiber plate, 18 mil thick, with a very good heat transmission value, a lambda, and in this plate the modular pipe, the Variprofile pipe, will be fixed and covered with a filling compound. The filling compound is for sure the product which is we are not common to work with. Pipes and plates, yes, but we need the filling compound to transport the energy from the pipe, from the water through the pipe on the surface. That is the job from Variotherm, to optimize and to reduce the resistance between the water and the surface. When you look to this picture, that is for sure the way an underflow heating system should look like. Perfect piping, a very good average temperature on the floor. When you control many installation, it is for sure not like that. A situation, I'm sure you can follow me, or you know that when the piping is not perfect, the people know exactly after a while where is the warm area, the warm pipe, especially in the bathroom when they run around barefoot. When the piping is not good, so for sure the comfort will not be fine. With our plate, with the 100 mil center between the knobs, it is possible to make a individual piping. On one hand, meander system is like a river, mostly used for peripheral zones or very small rooms. Or you can do the bifiller system. Many dry floor heating systems are not able to do both. Mostly are used the meander system. And in bigger rooms, the meander system alone will not bring a very comfort and good average temperature on the surface. On the other hand, our Variotherm system is very fast in response. So the control with the room thermostat and the heat up time is an important point. So the Variotherm system, when it is switched on, you can feel the temperature on the surface in 15 minutes. And it is much faster than any other underflow heating system on the market. A normal street flow heating system takes about 2.5 to 3 hours longer to be recognized in the room. The same is on the other side. When you switch off the heating system to cool down, it's important for the control when the sun comes out and into the room. And rooms with a concrete underflow heating system are very often overheated because of this situation that the system will not react fast enough. So it's important also that the system that you see here, the red line, is the Variotherm system. The blue is a normal concrete underflow heating system, and this is the flow temperature. When it's switched off, it cools down very fast. That is a good and important point from the Variotherm underflow heating system. You see here the filling compound, that is the surface after installing the Variotherm system. This is the ground surface to lay a floor on top. This is not the end layer, and you see here the filling compound. Once again, this is important to distribute the temperature from the pipe to the surface. The modular wall is the same material, gypsum fiber plate, 18 mil thick, but the pipes are already in the plates. We offer 10 different sizes on plates with different pipings to be flexible, to cover the walls and the ceiling surfaces. Why is a wall important and necessary to make a comfort climate? The radiant heat output, when I talked before, is perfect in cooperation with the wall. When you look to your profile from the floor or from the ceiling, it's a very small profile, but from the side, it's a very big profile. So I can interact with my radiant heat extremely good with the wall. So the model panel and the pipes are already inside. We do have a pipe distance all the time from 75 millimeters in the pipes. And you see here how a project can look like. You need on the wall less square meters than on the floor. Here's the manifold. The flow goes into the cold section in the corner of the room, and the plates are connected to each other, maximum 80 meters in one loop. A big question all the time is, oh God, pipes in the wall, how can I hang a picture or do fix something else? Yeah, we do have a pipe locator. The pipes are multi-layer pipes. There's aluminium inside, and with beep, 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 you find every 75 millimeter the pipe. Between you can hang a picture or do a screw, or with thermostrips it's the same, but in this case it must be heated up. Thermofoil change the temperature between 25 and 30 degrees. Here you can see the parking position. The pipe is taken out here for the connection from one plate to the next one. I want to bring the focus here to this angled surfaces. They are perfect for heating and cooling. Very often used. These surfaces are not covered with pictures or with furniture, free. There are no lights inside, so please take that with you when you have such a surface, and you will see later a picture from realized projects. This is really perfect for heating and for cooling with our modular plates. The installation, you need an under construction, starts from metal or wood, and therefore you screw and fix the plates. I hope we do not have a full plate here. In all our plates are marked with pre-marked where the screws should be fixed. So don't worry, you will not touch or screw into the pipe. All the panels are on the room side. Important information. This is the back side. So this is the room side. The plates are ready to paint. You fix the plate is the wall and the heating and cooling in one product. So this is ready to paint, and the output power from a wall heating is about 111 watt with 37 degree flow, so very low flow temperature with 20 degree room temperature. And for cooling, the same surface for heating and for cooling, the cooling is about 50 to 55 watt per square meter. You all the time need more energy and more surfaces for the cooling as for the heating. The cooling load is bigger than the heating load, and the output from a heated surface is bigger than from a cool surface, because the difference between the room temperature and the surface is bigger in heating as in cooling. Plastered wall and ceiling, I show you a picture. I hope you can see it enough that here is pipe on the ceiling, pipe on the wall. This is a daily life project for us in Austria and Germany, when we can reach with the designer, with the customer, a nearly perfect situation. All surfaces are heated in winter and cooled in summer. That guarantees the lowest possible flow temperature and the lowest possible energy consumption. Here, the ceiling pipe completely. And you can do only once this. When the plaster is on or the walls are plastered with plates, you will never do it again later on. So that's a big impact. What we have to do as information to our customer, that it is really important to think about what to do and how we can do a comfort climber also for the future. The last surface what we have to talk about is the ceiling. The ceiling, the modular ceiling from Variotherm depends on the same plates as the wall. The same 18mm gypsum fiber plates, the same sizes, but only installed on the under construction on the ceiling, with the difference that very often it is not the whole ceiling, it is very often just a part of the ceiling. In this case, you see an office, which is renovated, many years long only for underfloor heating. Then they changed to a heat pump in this building, and we call this cooling sails. It's very easy to install. You don't have to cover the whole surface, just some parts of the ceiling. In this case, with another color, and a perfect climate later for the people who works in this office, especially in the summer when the ceiling sails here are cooled. Sorry, not the output. An important point for cooling surfaces is the dew point. I'm sure you heard about that, and you think, hey, what's going on with the moisture, with the dew point? Yes, this is a part what we have to take care, that the dew point will never reach on the surface from cooled surfaces. The dew point depends on the humidity in the air and on the room temperature. When these two come together on the critical point, water, the humidity in the air will become to water on the surface. We all know the situation very well in a bathroom when the mirror becomes foggy. This is exactly the point when the dew point is reached and the temperature becomes too low on the mirror surface, then the water from the room, in the bathroom, especially when you come out from the shower, the humidity is very high, and on the mirror it is the first surface where the dew point is reached. You can avoid that in a bathroom when you do a wall heating behind the mirror. Be sure you will never have a moistened mirror again. For our normal cool surfaces, we have to take care that we do not reach this point. The dew point is shown in the Modular diagram. It's not so important, just want to show you that along this line is the critical dew point. What can we do? The first thing what we have to do is to choose a flow temperature in a cooling system which is mostly over the dew point. So we cannot go with 10 degrees water temperature, then for sure the surfaces will become wet. And that's the reason why the range for the flow temperature for cooling surfaces is very limited. We can go with 16, 17, 18 degrees. So only 3-4 degrees is the whole range for cooling surfaces. That's really strange on one hand. And to guarantee that the dew point will not happen when let's say a high humidity is coming with a rain outside in the summer when it is very warm. You open the window, humidity comes to 70-80 percent. Is a dew point sensor to measure the dew point on the surface where it can happen and stop the flow, for example, from the circuit with the actuator, or stop the pump, that the surface will be not cooled anymore. That's on one hand a problem, because with cool surfaces we cannot really guarantee a fixed and constant air temperature, and for sure not a very cold air temperature in rooms. But the good message is, with cooled surfaces you have a higher comfort with a temperature, a higher temperature as with air conditioning. But the dew point limits the output from cold surfaces, and that is something what we have to handle and accept. But please do not worry about that. The result from cold surfaces, is perfect. Your customer will honor that with very, very good feedback when you start to cool a little bit the surfaces around us, especially the ceiling. The last product what I want to show you from us is the acoustic ceiling. Acoustic ceiling means that we have holes in these plates, so we expand the use of the plates with one stage more. It is heating, cooling, the ceiling, and an acoustic reason in one product. Normally you need 2 or 3 to cover all these needs. How does it work? In the plates are holes. We have 3 different hole sizes, 12 mm, 8 mm, and 6 mm. The noises are going through the plate in the under construction and will not come out anymore. What we designed with our acoustic plates is an optimal situation for the middle frequencies from noises, which is mostly dependent to our voice. So designed for offices mostly, or where many people are coming together. The problem from why do we need that? The modern design from rooms and houses depends on smooth surfaces. And smooth surfaces, the echo sound is very uncomfortable for ourselves, for the ears, and we can reduce this echo sound when we create a resistance, and in this case with these holes. But holes alone, when you see holes, is not a guarantee that the sound reduction is perfect. We need that the noises come through the construction. And with our product, this is guaranteed. We are certified with our acoustic sound reduction by an certification in Germany, and we are the only company for heating and cooling ceilings with acoustic where certification is existing. The capacity for cooling is about 55 to 60 watt per square meter from a ceiling cooling. Ceiling heating is a very special moment. The output power is about 68 watt. When you remember, the wall was 111, but so it's a smaller output. But to heat rooms with the ceiling is depending on a very good conditions. The room is not allowed to be higher than 3.5 meters, and the flow temperature must be very low to heat rooms with the ceiling. But it's possible. We heat a lot of offices just with the ceiling, no floor, no radiator inside, just the ceiling. When the heat demand, the heat load is very low, it's possible to heat rooms with the ceiling. That's a lot of projects are done with that. This is a drawing from our technical department. You can see here acoustic ceiling plates, and here normal modular plates without acoustic holes in the project. Just one sheet to our skirting radiators. You have heard from me that this is our first product, designed many years ago for my father, but still a very interesting product. When you cannot make an underflow heating system, it is the way from a normal radiator to a wall heating system, because the energy is distributed over a long distance along the cold outside walls and cover the outside walls for our comfort. And it's very individual, and they look like with a wooden cover or metal cover, our skirting heating system Delta. You will see later a picture from a realized project. We are producing trench heaters to cover big glass walls, but not to heat the rooms. We are not offering trench heaters with fans, only with natural convection. The idea is to cover the cold glass influence on the glass side, and the room is heated by an underflow heating system or wall heating with a low temperature. We are offering 2 grills, and a linear grill like this here, or the roll grill you can see here on this picture. The pipe I explained before. The special on our profile pipe is the structure on the surface. The 11.6 pipe is 10% bigger than 11.6 pipe without the structure. The 60 mm pipe is 50% bigger. That brings an optimized heat transfer from the water to the surface. That's the idea and part of our success. I told you before the manifold, only two points about the manifold. We do have air chambers in the manifold. This is an insulation, and the manifolds are perfect for cooling, so the elements can't condensate on the surface because of this insulation. And the other point from our manifold is that the flow meter starts with 10 liter per hour on flow, which is a very low flow. Most of the other manifolds on the market start with 30 or 40 liter per hour, which is for low energy houses a little bit too much. Coming to the end from my presentation, I show you some projects from us realized in all these years. Do you remember that surface here, perfect for heating and cooling, free from with pictures. I hope you can see this here. This is a modular wall heating system in a very old house, a renovation. The architect has chosen that the wall heatings are to see with a color, LED light around, very individual. It's individual is an important word for the work from Variotherm. Modern interior. Again, this place are perfect for our modular plates. And ceiling project in a government building in the south of Austria. You can see here the white panels are the cooling panels. You see here the cooling sail, not the whole surface is covered. Nursery situation, typical for Variotherm underflow heating system. Kindergarten, this is the situation where the control, the response time is so important. Big glass influence when the sun comes out, or when a lot of people, childs in this case, are inside, internal loads, so the control from the system can work properly. Here you can see a skirting radiator. I hope you can see that. Yeah. Covered with the same wood as the interior here. Education, university in Austria, one of our first projects, a public project with Variotherm system. We got this project just about one reason. Original was planned concrete underflow heating system, but believe me, it is true. When the building company filled the room with the concrete, the installation company was not doing the piping, so the piping was missing. And the answer was our Variotherm system. You can see that here on the first stair. It's a little bit, the height is not so big than the other stairs. 20 mils are lost, but still an underflow heating system. And from time to time, where we can deliver just about that. It's not a joke, but it's a special situation. We are happy to have in Cambridge University, near to London, for a long time ago, successful with wall heating and cooling in drywall construction and modular plates. The same, and a very nice project in Jersey Island between England and France. A very old light tower is renovated into a hotel. The plaster was removed in this old building, and we are very happy that the owner of the hotel has sent us an unbelievable positive feedback from the new climate in this house and from the very low energy consumption when you do a piping like that. Big surfaces and a low temperature will guarantee a very high qualified climate and a low energy consumption. We are successful in churches, mostly renovation from churches, very often with our skirting rats inside of the sitting, the benches, or Variotherm underflow heating system in the areas where the people are sitting and walking. It's many churches are renovated now in Europe and brought to a standard where the people are happy to go in, because it's very cold sometimes in the churches, even not only in the winter, even in the spring and autumn. On the other side, a new and very modern office building will bring the focus to the acoustic solution here, which is acoustic heating, cooling, and the ceiling in one. Typical situation: smooth surfaces everywhere, glass, smooth floor, without its acoustic sound reduction. In this case, the acoustic, the noises in this big room in the area will be very awful, and it is really perfect. And also this owner of the company gave us a very good feedback. The ceiling is not the only system. You have a lot with the ceiling, acoustic ceiling. We do have the pipes in the concrete slabs, and in some areas a normal street underfloor heating. And the last project that I want to show you is a funny project in Netherlands. It is a renovation from a horse stable into a restaurant. Yeah. Netherlands is very tricky. We do have some churches. I know from 2-3 churches which are renovated to a restaurant. Yeah. Crazy Netherlands. But what I want to tell you about this project is the goal was the time. We had, not we, our partner, the installation company in Netherlands, had 3 days time to remove the old floor, do an underfloor heating in, and bring in the new floor, the wooden floor. And it is possible with our Variotherm underfloor heating system. The result is really perfect. You see the piping here, and it is done in 3 days. Very often an issue, time. Time is money. Yeah? The system, the square meter, maybe is a little bit more expensive than just a pipe, but the total project can be cheaper than anything else. And in this case, it was the situation that the Variotherm saved a lot of money for the owner, because he had to open the restaurant in a short time. Yes, I know it is not easy so long time to listen to, especially to my English performance. I hope you can take some with you for the comfort, for the future, from your future projects. It's very easy to follow a comfort way when you think about the heat output from the human body, to reduce the delta between us and the surfaces. Try to heat and cool as much as possible surfaces, the floor, the wall, and the ceiling, and you will have a very positive feedback from your customers. Well, I thank you for the possibility once again to talk, for honor people here, and yeah, that's it from my side. Thank you very much.
That's good. No, hey, look, thanks very much.
Thank you, man.
Yeah, appreciate you coming and sharing that with us. And look, there's lots of info from Variotherm, so if you're interested in more, we're certainly happy to help you. It's a pretty special product and a special company.